We have been speaking about signals. Now it's time to talk about continuous time systems. Systems may be represented by block diagrams, like this is one system, another system, and they can be interconnected. The way we connect the systems, we could have parallel connection or cascaded or in series connection, series or cascade connection. So those are connected in parallel. So the input goes at the same time to system 1 and same to system 2. This is parallel processing. And then we can add or multiply or whatever we do with the output. In the second case, we have the first system process a signal, and then the output goes to the second system. This is called series or cascade connection. Now we need to learn how to deal with block diagrams and interconnect them, because we need to develop models for physical systems. And remember that we said modeling can be one of the most difficult and time-consuming tasks for engineers. We're going to make some assumption. Sometimes, for example, we assume that we have the characteristic of the system, the input and the output, and then we take the output connected as if the system does not affect each other. This is in the ideal case. However, in real systems, like circuits, if we build one block and the second block will load the first block, for example, and we have some effect. So we cannot study them totally separately unless we assume they are ideal, and then we have high impedance at the output or high impedance at the input, so they don't affect each other. But we know that this is not true, and we require some impedance matching. We cannot just deal with the blocks completely separately unless they are ideal, which is what we do in terms of simplification in this course, in most of the cases. Here is an example of interconnected system, a bit more complicated. So the input X goes in parallel to 3 systems. The output of system 1 and system 2 get added here and then fed to system 3, and the output of system 3 is also multiplied by the output of system 4 to generate Y. I'm using colors here so you can follow up with the equations. So we can say, for example, Y1, the output here, is the transformation or the operation of the system T1, the subscript represents the system, on the input X. We can also say that Y3, which is output here at this point, is nothing but the sum of the output of system 1 and system 2. Then we can say that the final output is the multiplication here. The multiplication, it's implicit here, that we took the first 2 outputs and then we got them through big bracket transformation of system 3, and those now outputs are multiplied. We have another example, very common example here of the summation and the feedback loop. So feedback means we take this is for feed forward, because all the arrows are going from the input to the output. But in some systems, of course, a very popular system, we need feedback. We need to take the output to adjust the input, like in feedback, control, automatic control. So the basic principle is that we take the output and then we adjust. Usually there's a minus sign here, we call it negative feedback, to adjust the output. At this stage, we just want you to get used and familiar to the block diagram. But in other courses, control courses and what have you, you will learn more about the details. Usually we have summation, multiplication, we have blocks, arrows. You should be able to express the system and the signals. And the signal E, for example, here is nothing but X minus Y3. The system here is the transformation of E, and so on.